Why is childbirth in humans so painful, dangerous, and bizarrely difficult compared with almost the entire animal kingdom? Why can a newborn giraffe or zebra fall from its mother's womb, stand up, and start stumbling around within 30 minutes, while a human newborn is a helpless bundle of soft flesh, completely unable to fend for itself, crying almost constantly and revealing its location to predators for years? How did a primate with no claws, no sharp fangs, slower legs than a cheetah, and less physical strength than a lion manage to keep its fragile children alive through the jaws of the Pleistocene's most terrifying predators and eventually dominate the planet? To solve this great evolutionary mystery, we first have to uncover one of the most famous biological dilemmas in anthropology, the childbirth dilemma, also known the obstetric. For decades, scientists have struggled to understand why nature made human childbirth so dangerous to both mother and baby. The answer begins with the moment our ancestors committed to walking upright on two legs across the African savanna. In 1960, Professor Sherwood Washburn, a distinguished anthropologist at the University of California, Berkeley, proposed a groundbreaking hypothesis. As our ape-like ancestors shifted from climbing trees to walking fully upright on the ground, their entire skeleton had to be redesigned to support their body weight, to walk efficiently and run for long distances without damaging the spine. A mother's pelvis had to become narrower, creating a tight, curved birth canal. Bipedalism was an extraordinary biological innovation that freed the hands for grasping and using tools. But the price of walking on two straight legs was a dangerously narrow passageway for childbirth. The biological tragedy was that as the mother's pelvis became narrower to support upright walking, the human fetal brain began expanding at a remarkable rate. Thanks to energy-rich foods such as meat and bone marrow, the skulls of early humans, such as Homo erectus and Homo sapiens, became roughly 2 or 3 times larger than those of Australopithecines. Imagine trying to push a giant watermelon through a narrow plastic tube. A human baby cannot simply slide straight out like a gorilla or chimpanzee. The baby's head has to perform an astonishing sequence of rotations, turning sideways to pass through the upper pelvis, then flexing and rotating 90 degrees to navigate the lower pelvis, and finally emerging with the face turned toward the mother's back. Renowned anthropologist Wenda Trevathan of New Mexico State University spent much of her career studying the evolutionary origins of human childbirth. She pointed out that this face away from the mother position creates a deadly risk. The mother cannot simply bend down and pull the baby out with her hands without risking damage to the baby's neck or spinal cord. Pulling the baby from the front could also tighten the umbilical cord around the baby's neck and cause suffocation. In other words, giving birth alone in the wilderness was potentially a death sentence for a prehistoric woman. To solve this brutally difficult biological trade-off, natural selection produced a strange compromise: evolutionary premature birth. Human babies are essentially born before they are fully mature, neurologically and physically. If a human fetus were allowed to develop enough to be as neurologically and physically capable as a newborn chimpanzee, a human pregnancy would have to last around 21 months. But if the fetus stayed inside the mother for 21 months, the baby's head would become so large that it could tear through the mother's pelvis during births. So, nature effectively had to push the baby out when its brain was only about 25% of its adult size. And what was the result of that compromise? Human babies are born almost completely helpless. A newborn antelope can flee from predators within hours. A baby monkey can use its strong fingers to cling tightly to its mother's fur while she leaps from branch to branch. A human baby, by contrast, can do almost nothing beyond breathing, nursing, and crying loudly. It cannot hold its head up, crawl, regulate its body temperature on its own, or survive without round-the-clock care for years. Now place that soft, helpless newborn and its exhausted mother on the African savanna 2 million years ago. This was not the peaceful grassland of a picture book. It was a deadly landscape, filled with some of the most terrifying predators the earth had ever seen. The first threat came from the giant saber-toothed cat, Dinophelis. With a powerful body, weighing nearly 200 pounds and dagger-like canine teeth, Dinophelis was a formidable predator of ancient primates. During excavations at Swartkrans Cave in South Africa, renowned paleoanthropologist Charles Brain discovered skull fragments from prehistoric hominin children with 2 perfectly round puncture marks on the top of the skull. The spacing of those punctures matched the distance between the upper canine teeth of a Dinophelis with remarkable precision. The evidence suggested that saber-toothed predators of that era sometimes stalked around the bushes, snatched vulnerable young hominins, and dragged them into caves to feed. The second threat was the giant short-faced hyena, Pachacracuta, about the size of a modern lion and armed with jaws powerful enough to crush the bones of large prey. These hyenas had an extremely sensitive sense of smell. They could detect the scent of blood and waste from remarkable distances. If a mother made even one mistake while hiding in the brush, a hungry pack could rush in and tear apart anything in its path within moments. And the danger did not stop there. It could also come from the sky. In 1924, anatomist Raymond Dart discovered the famous Tong child fossil in South Africa, belonging to Australopithecus africanus. When scientists later examined the child's eye sockets in detail, they found scratches and deep punctures that were interpreted as consistent with the talons of a large predatory bird. Prehistoric eagles with wingspans exceeding 10 feet may have been capable of diving from above, grabbing a vulnerable infant from the grass, and carrying it away in an instant. So how could your fragile ancestors possibly protect themselves and their helpless children within such a dense web of deaths? The answer was not individual muscular strength. It was one of humanity's greatest social innovations: cooperative breeding and the rise of communal mothering. Because a woman could not safely give birth alone in the wilderness, humans effectively turned childbirth into the first team sport in history. When a woman went into labor, she was not left alone. Experienced women in the group, including older mothers, sisters, and aunts, would gather around her and form a protective circle. They could support the baby's head as it rotated through the birth canal, gently free the umbilical cord if it was wrapped around the neck, clear fluids from the baby's airway, and cut the cord with a sharp stone. The presence of these prehistoric birth attendants was not merely primitive medical assistance. It may also have provided invaluable psychological and biological support. Gentle touch, reassuring sounds, and close physical contact from other members of the group could help calm the mother, support the release of oxytocin, encourage effective uterine contractions, and potentially shorten labor before the smell of blood attracted predators. After the baby was safely born, the burden of raising it continued to be shared by the entire community through cooperative care. Anthropologist Sarah Blaffer Hardy of the University of California, Davis, has argued that humans developed an unusually strong system of care in which people other than the biological mother could carry, protect, feed, and care for an infant from the earliest hours of life. In an ancient hunter-gatherer community, newborn might be passed among 6 to 8 different adults over the course of a single day. And there was one especially powerful figure in the survival of prehistoric children: the grandmother. Anthropologist Kristen Hawkes of the University of Utah proposed the famous grandmother hypothesis to explain why human women experience menopause and often live for decades after their reproductive years, a trait that is unusual among mammals. In the harsh prehistoric world, a young mother who had to carry an infant while also searching for food could quickly become exhausted or leave her child dangerously exposed. But a healthy grandmother, no longer caring for her own infants, could gather energy-rich roots and other foods, watch over children, and help protect them in a safer shelter while the mother searched for food or recovered her strength. Anthropological field research has suggested that children with living grandmothers could have substantially better survival prospects than children whose grandmothers had died. To picture this extraordinary survival strategy more vividly, let's recreate one tense evening from about 1 million years ago in a rocky shelter at the foot of the Great Rift Valley. Imagine that you are a young Homo erectus hunter, wearing nothing but a rough strip of antelope hide wrapped around your waist. In your hand, you grip a wooden club whose tip has been sharpened and hardened in fire. Night has just fallen, covering the valley in a cold, dark indigo. Wind whistles through the cracks in the rocks, carrying the earthy smell of mud and the terrifying calls of hungry hyenas prowling less than 50 yards from the cave entrance. Their glowing eyes flicker in the darkness like tiny sparks of death. Inside the rocky shelter, beneath the pulsing red light of the campfire, your sister is kneeling on a bed of dry leaves. Sweat covers her forehead, and she bites down hard on a piece of wood to keep from screaming as another wave of labor pains surges through her. Beside the young mother, a silver-haired grandmother with rough, calloused hands gently massages her daughter's lower back. She keeps making soft sounds in her throat to calm her. 3 other women from the group sit directly in front of the mother, creating a living wall that blocks the view from outside. At the cave entrance, you and 4 other strong men remain completely alert. You keep feeding dry acacia branches into the fire, sending sparks into the air. The fire is your ultimate weapon. an invisible wall separating your family's lives from the teeth of the predators outside. Suddenly, a sharp newborn cry echoes through the shelter. The baby has arrived safely. The grandmother quickly uses a sharp piece of stone to cut the umbilical cord, wipes the blood from the baby's body with soft leaves, and immediately places the naked infant against the mother's warm chest. The moment the baby latches onto the breast and feels the familiar rhythm of its mother's heartbeat, the crying stops. The entire shelter falls into absolute silence. Outside the cave entrance, the lead hyena steps forward, growling deep in its throat as it catches the strong smell of blood and placenta. But at that very moment, you step forward too. You raise the flaming wooden club high above your head and stare directly at the animal, releasing a deep, commanding roar, the kind of sound that announces a species that has mastered fire. The hyena freezes, then lowers its tail and retreats into the darkness. Inside, the newborn sleeps peacefully in its mother's arms, surrounded by the love of the grandmother, the care of the women, and the determined protection of wooden spears. Tonight, human life has defeated the darkness, the teeth, and the claws. This survival strategy leads us to a profound and surprising turning point in our understanding of what makes our species unique. Traditional textbooks often teach that humans conquered the planet because of our superior brains, sophisticated tools, or great technological inventions. But the evolutionary story suggests something almost opposite. The extreme weakness of our bodies may have been one of the forces that drove our greatest achievements. If human babies had been born strong and able to run like newborn antelopes, mothers would not have needed as much help from the community. If childbirth had not been so dangerous, prehistoric women might have been able to leave the group and give birth alone in the forest. But because babies were so helpless, mothers were vulnerable, and the pelvis was so constrained, humans were pushed by nature to bond with one another through some of the strongest emotional ties imaginable. To keep a helpless child alive among predators, the group had to develop empathy, emotional awareness, complex communication, and sophisticated cooperation. The vulnerability of human infants may have helped drive the evolution of love, generosity, and communal culture. We did not become social because we were already intelligent. We had to become social to protect our helpless children, and that cooperation helped create the conditions for our extraordinary intelligence. When you look at this great evolutionary picture and compare it with modern life, many everyday frustrations suddenly become easier to understand. Have you ever wondered why you feel an intense rush of anxiety when you hear a baby screaming in a coffee shop or on an airplane? It may not be because you are impatient. Your nervous system still carries ancient alarm circuits shaped by the lives of prehistoric hunters. For much of human evolution, a baby's cry was a high-priority signal that something was wrong and that the child needed immediate protection. Have you ever wondered why modern parents can feel exhausted or overwhelmed when they are raising a child alone inside the walls of a small apartment? Human biology was not shaped around the idea of one or two adults doing everything by themselves. Our minds evolved in social groups where grandparents could hold babies, aunts could help prepare food, and other members of the community could share the burden of protection and care. The old saying that it takes a village to raise a child is not merely a poetic metaphor. It reflects a deep social pattern that helped human beings survive and avoid extinction.